Hi, welcome to this Open Security Summit session in 2022. We have Ben and Jeroen who are going to talk to us about OWASP Wrong Secrets and the project and what's happening, and they go from here. Over to you.
Thank you so much, Dennis. All right, so welcome to our talk about our new project, OWASP Wrong Secrets. As you might know, we're recording this and we have a Zoom chat open, so feel free to ask any questions at the Zoom chat, so we'll try to answer those at the end of the presentation. Or if you have any remarks or whatever, just drop them over there. We'd love to hear from you. Let's get started. A little bit about me. I'm Jeroen Willemsen. I'm one of the project leaders. Work at XIB as our principal security architect. And over to...
Yes, me. I'm Ben Dehaan, and also project lead for OWASP Wrong Secrets. I work as a security engineer and consultant. Back to you.
All right. Thank you so much. So, first biggest question, can you keep a secret? I think that's been a question over for us as humanity for ages. How well can we keep our secrets? Whether it was in the Roman age when certain orders needed to be securely submitted to another set of soldiers at the field, or whether it's today when you actually got the secret shared from your friends or a secret shared somewhere else. It's really been a challenging subject. Even more in the context of the DevOps currencies and stuff like that, because as you might as well know, there is an abundance of ways on how you can keep secrets currently in our infrastructure and in our applications. So the major question is not only can you keep a secret yourself, but can you also write applications that can keep their secrets well, or can you make sure that your infrastructure holds a secret well? That's actually a pretty difficult question. Can we do that correctly? Because what is a secret? There are so many different types of secrets. Think about private keys, think about API tokens, credentials, OTPs, private GPG keys, signing keys, encryption keys, HMAC keys, you name it. There's so many different things out there. And don't forget about MFA backup codes and lots of other different things that might actually still require to be a secret. Well, I'm pretty sure while you're watching us right now presenting this, you already have an idea about how to manage secrets or how to work with that. And if not, then, well, hope to inspire you how to not do it. Because when we talk about secrets, yeah, let's assume that you have a Kubernetes cluster running. Where would you store the secrets? I'm pretty sure you wouldn't store it in your code of your application, right? Hopefully. Nor in your container, or maybe you do, because hey, if the container is out there, who might possibly be able to see it, right? Or what about your Kubernetes service itself? Doesn't it hold something like Kubernetes secrets? Is that really the place to manage this properly? Or maybe you have a secrets manager deployed. What about your platform providing solution? Like, for instance, you're running Kubernetes on AWS, in AKS or whatever, and you use your AWS Secrets Manager or something similar. Or maybe something else. Where do you keep your secrets actually? And more importantly, do you know? The way you would even easily understand whether you do is ask yourself if you have to rotate all the secrets of your organization because there's a serious incident that basically covers everything. Do you then know where the secrets are? Do you actually know why they are a secret and what their purpose is? And can you rotate them timely? And there's so many other questions you might ask yourself to get a little bit of a feeling of, hey, am I really in control of the secrets management thing over here? So then, of course, there's also monitoring and access logging, right? Can you, for instance, tell us when that was the last time that the secret was accessed? And by who? And for which reason? And do you also know when the secret was no longer serving its purpose, when the secret no longer worked? For instance, you had some credential for another system stored in your own application, and now all of a sudden that credential no longer works at the target application where you authenticate to. Do you know? Do you have a feeling for that? And when you actually log that, do you make the same mistake as this little guy over here? Do you actually log the secret itself then, or are you in check? lots of different questions. So apparently, secrets management is special, right? In its own very special kind of way. There's so many questions you might ask yourself, as in, hey, are we really getting to grip on this? Do we actually know what we're doing? These, I think, are very valid questions, and are actually the reason why we started Project Wrong Secrets, which is, I guess, a great start to head over to you.
Awesome. Yeah, taking over the screen. There we go. So today we'll be talking briefly about Wrong Secrets, how it came to be, and what its goals are. We'll demo it on Heroku, on AWS. We'll talk about how it works under the hood. And finally, we'll touch upon where we want to go from here. And here, your input is especially valuable. If you think that we should build support for a specific platform, or you have a very cool idea for some secret management problem you saw in real life, then please let us know. Drop something in chat, ask questions, so that we can build a better product, essentially. Starting off with Wrong Secrets. So what is it? It's a vulnerable application, intentionally vulnerable, of course, and it demos various ways you should not store your secrets. And it's intended to also then make you reflect on how your own secret management compares. The target audience consists mainly of developers and security professionals. So that also includes the offensive side of things. We want to stress that, well, we think the offensive part is important. We think that actually preventing and resolving these issues are probably even more important. So we really want to educate the developers, educate the builder side of things, essentially. So that's probably our primary goal, right? Educate on secret management and the pitfalls that are there. We can also then help people running this application reflect on their own secrets management strategy, see what is wrong in our app, and then not only what is wrong, but also why it is wrong, and hopefully also how to fix it. These are things that we think of when building our challenges. And finally, we want to promote secrets management as an important facet of security, because it's often not one of the sexy things of InfoSec, right? That's the trouble with more of the builder stuff. But we really want to stress that this is an important part, and it can be fun to tinker with it. Now, I want to give a brief shout out to our contributors. Of course, we have the project leaders, but it's not only us working on the application. There's also Nana, who is also working on WebCode, Philip, Dimitri, some testers, Dave, Marcin, Mark, and Madhu and Björn, who are also immensely valuable, all of them, to what this project has become in a brief period of time. So quick shout out to them, massive thanks. Actually, Wrong Secrets is only a very young project. It's been a project since October, and we've only promoted it at AppSec Podcast and Club Cloud for now, but there's more to come. So this year's we have a number of conferences we intend we're planning to attend. So tune in if you like this project, and more to come. So enough talk on the description, etc. Let's show a bit of the application. So let's go over to Heroku, and we'll give you some links to where you can find all this if you want to run it yourself. We've got wrongsecrets.herokuapp.com, and there you can test at least some of the challenges working in a Docker environment. So if we enter the app, we see the challenges that we have in the app, and the challenges that are supported are highlighted. So some challenges require, for instance, Kubernetes, Minikube, or require a certain cloud like AWS, GCP, or Azure. Note that Azure support is still experimental, but the other clouds should work fine. Currently, we're on Heroku, right? And it also helpfully tells us that. Then we can, of course, move to the secrets, but we've also got a few resources on secret management. Let me zoom in a bit. Might be seeing it in slightly lower resolution. And these resources then tell you on how to actually do it correctly, rather than just showing you how it's not done. Some extra reading, if you will. Then the next thing we want to do, let's see first, we can also use this thing on mobile. It's built with Bootstrap, so pretty responsive. If you want to hack in this on your free time and you don't have a laptop available or anything, you can just go to this thing and hack on its own mobile environment. But let's jump into a challenge, because that's what it is about, right? So I'm highlighting challenge 3, and challenge 3 then gives me a brief description of what it is. So this is a Docker env based password. Gives me a brief description and maybe a hint on how to tackle this challenge. And if I really don't know what's wrong about this, then I could click this helpful button right here that says what's wrong. And this tells me that you shouldn't store this thing right in the container, since these things can be listed publicly, or if you have access to the image, you can easily detect what is in the layers and thus detect the in this case, the password. We can also look at the hints and see some, get a step-by-step walkthrough of how to solve this. If you run this in more like a CTF mode, then it's definitely possible to also turn these hints off. Now let's try and solve this one. So we see there's a Docker env based password, right? So what we want to do is inspect the Docker layers and see what comes up. Now, one very, very easy way of doing that is just going to the Docker hub where our images are published. So we're going to Jeroen Willemsen /wrong secrets, and then the latest one, which is tagged with 130. Let me zoom in a bit again, because it might be slightly unreadable. And helpfully, we see a Docker env password here. So let's copy this over. And yeah, if it's wrong, then it will tell you it's incorrect, of course. And if you enter the right one, then we'll see our answer is correct and our score will go up. Now, from here, we could go on, of course, until all the challenges have been solved. For Heroku specifically, that's not possible because we also need Kubernetes or AWS for some of the challenges. But this gives you a brief idea of what this is capable of, at least. Okay, back to the presentation. And let's talk a bit about how this works under the hood and the philosophy there. So our app is built in Java, with Spring Boot specifically, and then runs, like we said before, on a variety of platforms. And the idea is to provide challenges at all levels of this configuration. Now, we've seen a Docker-based challenge, right? In the container, the Docker env-based password, but there's also challenges that specifically target the application code, where something might be hard-coded, their config, for example. then it's running inside Heroku or a pod on Kubernetes. And we have some challenges for Vault or for Kubernetes specifically, like the config map and the secrets Jeroen was talking about earlier in his introduction. And then finally, this can be run on a variety of cloud environments, so AWS, GCP, Azure, or locally on Minikube even. And the idea really is to provide you with challenges at every layer of this architecture diagram so that you can really get a feel for which things work in secrets management, which things won't. So Jeroen, that's it for me with the under the hood part. Over to you.
All right, thank you very much. So maybe it's a nice idea to zoom a little bit in how does our code looks like, how is it structured, to get a bit of idea of the project. After all, this is the first time that we're giving a tour of the project itself. So let's go to IntelliJ. Hopefully that's right now. On top of it, I hope you can see it right now. This is basically our Wrong Secrets repository, which starts with the basic README, as you can see on your when you go to GitHub, for instance. It consists of a Spring Boot application written in Java 17, where we have the challenges defined as a set of challenges for the cloud environment, for the Docker environment, and specifically on Kubernetes. Next to that, we have a set of Kubernetes definition files for your local Minikube deployment or any other running cluster which you want to enrich with this application to play around with it. And after that, there's 3 folders from which you can basically boot up your cloud environment, so AWS, Azure, and GCP. The idea is that in all cases, when you open up the folder, you'll find a README with specific instructions that will help you step by step to go through setting up the environment. And that's been tested by multiple testers as well to make sure that it should be a painless experience. Of course, one thing to note about the cloud environment challenges is that cloud infrastructure is not necessarily for free. So when you ever try this out, make sure you have an account somewhere and that you have enough credits or that you are covered to make sure that the expenses are not too high. We made sure in all cases that the infrastructure required for the challenge is as minimal as possible. So it's not like we're going to set up very beefy instances of lots of things, or we're going to make you use reserved AWS instances. None of that. All is spot based. All is based on, for instance, EKS, AKS, and a simple Kubernetes cluster in Google and GCP to make sure that the cost is very little. We include tearing down instructions to make sure that once you're done, you can also tear it down again without adding additional costs. Which actually brings us to a very nice next step, which will be our AWS demo. So let's go over to that. So over here you can see a terminal, which is where I basically did the Terraform apply steps. Let me zoom in a little bit. So that basically asked me, hey, do you want to create all this fancy infrastructure on AWS, a full-blown EKS cluster, secrets manager instance, and lots of other things? Roles for IAM, etc., because all these things are required, as you'll find out later when you try to test yourself. And then after it starts spinning up, when it says all done, we basically have it all created. You then follow the other steps, which are nicely defined, and we end up with just doing our startup script, which will boot up console or deploy console to our Kubernetes cluster or EKS cluster. We'll deploy Vault over there, and we'll deploy our Wrong Secrets application. Once all of that is done, it basically, for now, still does port forwarding. So we end up with, well, port forwarding towards localhost, which we, of course, can use, because the moment we then go to localhost over here, you'll see that at localhost support forwarding, we actually now have a full-blown application running, because now all the challenges are highlighted, which means we can now play around with everything. Of course, we don't want to spoil the fun for everybody, so we just want to give a small demo of just the first challenge in AWS, which is actually similar for GCP and Azure. So let's do challenge number 9. So in challenge number 9, we've been generating a secret for you through Terraform, and we stored it with our cloud provider. And we did it as simple as possible. And now the big question is, of course, what happens in the Terraform state? So for those who don't know, if you use Terraform, then often there's Terraform state created, which is used for state keeping, literally, of the state of your cloud provider and what changes have been applied and what not by means of Terraform. And in our setup, this is all stored locally, so you can inspect it yourself and understand what might be the problem. So you can try to find the secret by sniffing through Terraform TF state files using Trufflehawk. So that's one solution. We'll take in a little bit of an easier path for now by just opening up the Terraform state file and give a little bit of an idea of what's happening. So in my, I'm right now in the folder, basically, OWASP Wrong Secrets, the AWS folder. So let me open that up in Visual Studio Code. And when I open that up, I end up with, for instance, a Terraform state file to be read over here as well. I hope this is visible. And then you see all sorts of resources that have been created, like, for instance, IAM roles that have been created and many other things like secret manager secret definitions or meta definitions that tell that there is a certain secret deployed as a secret manager without any secrets inside, for as far as I can see over here. But from what I've understood, we're basically looking for a secret or password that we've been generated. So once we start looking for the password, we can go a little bit around. And now over here, we find a AWS SM parameter. It's named as secret. So yeah, that's the secret that we've been generating apparently. And it says, okay, there's a bunch of metadata about, okay, where did we store this? So this is stored in SSM. That's the parameter store, or maybe we stored it somewhere else or moved it around later on. But more importantly, what we'll see over here is that that there's actually a secure string with a value. That's interesting. Maybe if we copy the value, we'll actually go somewhere. So if we, again, like the band showed, this is not something, some orchestrated demo. Is this orchestrated? Just to make sure. Well, at least it's not a secret, so I'm not sure how orchestrated this is. If we now put in the actual secret, there's the demo dots.
Yeah, it's the thing is you actually got the red herring. So this one is set through the Terraform state, but it's for a later challenge. It's not one of the actually.
Oh, yes, unfortunately, yes, I was looking at the wrong one. So here's the actual password copied, unfortunately. Here it is. Sorry, I was looking at the wrong part. Well, that's an interesting first time demo public. Here we go. So now we have to, as proven, it's really not orchestrated, because now it actually is correct. So this was indeed the secret we were looking for, which is indeed the random provider which is generated. So what does this tell us? So it basically tells that we have to be very careful with secrets in Terraform state. Of course, this is not the only part where we have to be careful with secrets in your cloud provider. There's a few more challenges that we'll talk about, how not to use IAM, for instance, and how to do a few other things in a much better way. But this will tell you already a lot. So much for our AWS demo. Let's which brings us to where to go from here. So yeah, what else is going to happen to the project? Because of course we showed a few things. And apologies for some of the technical inconveniences along the way. But yeah, it's the first time for everything, as we're just a really young project. But where do we go from here? So first of all, we want to improve the development experience of the project, because currently there's a little bit more work when you need to add challenges and you want to reload your screen every time. That's something that's been working on. We want to create solution write-ups, so you don't necessarily only need the application. You could also follow a separate instruction set to see how you can fix this. This will be mostly based on and synced with the current content of the application, so that we provide the same type of information in different sources. We want to add GitHub Actions-based challenges, of course, because nothing is more fun than combining CI/CD with secret management and find out that lots of people and lots of organizations are really in trouble. And of course, many other type of challenges are on our roadmap. For instance, the good old have your secret in the client side and obfuscate it by means of JavaScript in this one. We also want to add CTFD support, so you could actually make a CTF out of this for fun. Although, yeah, of course, you'll have to disable the hints, and still you can Google those, but it would still be fun to make a little bit of a more of a game, basically. We'll also put more effort in testing cycles with testers to improve the user experience. We get a bit more of a feeling of, hey, does this really feel right? Is the explanation correct? And if you're willing to join the tester squad, just send us a note either through GitHub or Slack or Twitter or LinkedIn. Just reach out to us. We would love to collaborate with you as well. And there's so much more, which you mostly can find at our GitHub in terms of issues at this point in time, which you can find over here, basically. Which brings us, of course, to the fact that we can really use your help. As we're just a young project trying to get these things covered, we would love if you could help us to promote this by giving us a star or sharing it to social media if you really like the project. If you could take the project for a spin and tell us what you think about it, that can also be done privately, of course, through Slack DMs or Twitter or whatever you would like. So we really get a feeling for, is this really the right direction? Does this really help you with your secret management, or at least to reflect upon the secrets management in the way you're currently doing it? And give us as much feedback as you can, basically. Of course, if you want to file PRs, we'll list you as a contributor in exchange for that, and would love to collaborate with you to make the project grow stronger. That's it. Are there any questions? Well, if there are no questions, then I would like to thank you all for your time. Oh, everybody can unmute to actually ask questions directly.
All right, questions, anyone? Don't be shy. Fine. All right, so there are no questions and we have to wrap up then. Oh, there's one.
That's actually a great question. So a question from Aram Hofspian. I hope I pronounce your name correctly. Thanks, guys. Seems very interesting thing. We'll definitely check it out for a cheaper question. Any way to work around the whole Google the answers? Yes, partially. Because for every new version of the deployment in the cloud, for instance, we regenerate our secrets. So it's not like you can copy paste a secret. You can copy paste the way how to obtain a secret, but it will be new every time. And on every new release, you'll find out that some other secrets within the whole challenge have been rotated as well. But I'll leave it up to the participants of the challenges to see which ones were rotated. And last but not least, some challenges are rotated upon reboot of the application, which makes it interesting as well. Of course, the methodology on how to find the secrets is hopefully something that's not too hard to Google, because it will help people to understand that, hey, if I can do this, so can everybody else, which also makes it less eligible as an actual CTF, but more eligible as a vulnerable app, which helps you to reflect upon the problems. Any other questions?
I think that might be it for questions. Obviously, I think if anybody else thinks of any, I'm sure they can pop you across a message and you'll be happy to answer.
Yep. Don't hesitate to
Brilliant.
reach out via the Twitter or email.
Fabulous. Well, thanks everyone for joining. Bye.
Thanks a lot.
Thank you so much. Bye-bye.